Okay, friends, we're here for another math lesson. We're in Module 4, Lesson 22, and the objective states, I will be able to compare the size of a product. So the skill is to be able to compare. We're comparing two things, the size of a product and its factors within a multiplication problem. So we're looking at the factors and how they change the size of the product. So let's go ahead and do a warm-up to get ourselves ready. And when you're ready, start the warm-up. And when you're done, come on back. Okay, so it looks like you're ready to correct. We have 1/2 times 6, and I'm going to put that over 1, would be 6/2, which is 3. 6 divided by 2 is 3. I have 2 over 2, or 2/2 times 6, would be 12 over 2, which is equal to 6. 1 times 6 is also equal to 6. 3/2 times 6, I put that over 1. I have 18/2, which 18 divided by 2 is 9. Let's go ahead and look at the second column. 1/4 times 8 would be 8 over 4, which is equal to 2. 4 over 4, or 4/4 times 8 would be 32 over 4. When you do the division, you get 8. 1 times 8 is 8. And then 5/4 times 8 would be 40 over 4, which is equal to 10. Okay, so before we move forward, I want to go ahead and try to look for some patterns between our warm-up problems. And this is going to help us out when we move into our problems. So if you notice, I have two products that are the same as the factors. And so that would be 6 and 6. I also have 8 and 8. And 6 is the same as 6 here. 8 is the same as 8. And the way that we get that is through the identity property, or we're really multiplying by 1. So we have 1 and we have 2/2. Those are the same as 1. And again, we have it here, 4/4 and 1. Those would be the same way to express 1, and that's why our product would be 8. Now, I want to move to the top row. When I look at the number 6, and I want to look at the product is 3. And so 3 is less than 6, and the reason why is we multiply by 1/2. If I look at 1/2, 1/2 is actually less than 1. And because it's less than 1, my product will be less than 1. Same here, 1/4 is less than 1. So my product is going to be less than 8, which it is 2. Okay, and then lastly, I'm going to go ahead and look at 3/2 and 5/4. And actually, 3/2 is greater than 1. So if it's greater than 1, my product is going to be greater than this factor of 6, which it is. It's 9. And then here I have 5/4. Oops. 5/4 is greater than 1. So my product here is going to be greater than 8, which it is. It's 10. So again, it's not about actually doing the multiplication. It's about comparing the size of the product to the size of the factors. So looking at the size of the product, which is what we have here, compared to the size of the factors. Okay, moving forward. We're going to look at these problems and think about what is similar in all of them. So if I take a look at A, B, and C, I noticed right away that they all have, or they all deal with multiplying by 12 inches. So then I'm going to look in red to see what do I notice that's different. Well, I notice that these factors, these first factors are different. I have 4/4, 3/4, and 5/4. And so what I want to do is I want to kind of explore what these fractions mean. So if I look at 4/4, 4/4 is equal to 1 whole. If I look at 3/4, I know that 3/4 is actually less than 1 whole. And if I look at 5/4, I know that 5/4 is greater than 1 whole. And so this is going to help us out, again, when we look to compare the product to the factors. Okay? So now I'm going to do the multiplication and compare the product or the answer to the constant factor. So it goes something like this. If I look at 4/4 times 12, I'm going to go ahead and put that over 1. I can cross cancel. I'm going to divide by 4. So this becomes 12 over 1, which is the same as 12. My final answer. So here's what I want to do. I'm going to compare my product to, which is 12, to my factors. Because I multiplied by 4/4, which is the same as 1, my product is equal to the constant factor of 12. So we have 12 is equal to 12. So let's take a look at B. I'm going to work out this multiplication. 3/4 times 12. I can again cross cancel. It's the same, dividing by 4. When I multiply, I get 9 over 1, which is the same as 9 wholes. Okay, so 9, here we go. If I compare 9 to this constant factor, which is 12, 9 is less than 12. The reason why 9 is less than 12 is because we multiplied by 3/4. Remember, 3/4 is less than 1. So if the factor is less than 1, the product will be smaller. Okay, lastly, we have 5/4 times 12. Again, I'm going to work on that same cross-canceling, dividing by 4. And I have 15 over 1, which is the same as 15. Okay, so let's compare the product, which is 15, to the constant, which is 12. And I know that 15 is actually greater than 12. And how did I get an answer or a product greater than 12? Well, this factor was greater than 1. So as we change these factors and the value, they can either be 1, they can be less than 1, they can be greater than 1. That changes the relationship of the product to the constant factor, which is the green factor. Okay. We're going to take a look again at a set of problems. We're going to see what's similar, what's different, and how that may impact the product. Remember, we're going to compare the product to the constant factor. So I want to look for the constant factor in this set, and it's definitely 1/3. Now, let's see what we're multiplying by. We're multiplying by 4/4, 3/4, and 5/4. So I know that 4/4 is equal to 1. So I believe that my product will be equal to 1/3, right? That's the green factor. If I multiply by 1, it'll be the same. Now, I again know that 3/4 is less than 1. So what do I think is going to happen with my product? I think my product is going to be less than 1/3. It'll be smaller than 1/3. And then lastly, if I multiply by 5/4, I know that 5/4 is actually greater than 1. So I anticipate that my product will be greater than 1/3. So let's see if this works out, and let's see if we can follow this pattern of factors and products. Okay, it looks a little something like this. 4/4 times 1/3 equals 4/12. Is 4/12 equal to 1/3? Well, if you divide by 4, you do get 1/3. So that would be correct. Next, if you multiply 3/4 times 1/3, I can actually do some of my cross canceling. I get 1/4. So is 1/4 less than 1/3? Actually, it is. 1/4 equals 0.25. 1/3 equals 0.33 or 33 hundredths. So 1/4 is less than 1/3 by just a small amount. And lastly, 5/4 times 1/3 is equal to 5/12. So is 5/12 greater than 1/3? Well, we would have to make equivalents, and in order to do that, we would multiply, or we would multiply times 4 times 4. So 5/12 is actually greater than 4/12. So as you see, again, we've proven and we've followed the pattern that when you have a constant factor, and in this problem set, our constant factor is 1/3, when you multiply by 1, your product is the same. When you multiply by a factor that is less than 1, your product is less than that factor. And when you multiply by a factor greater than 1, your product will be greater than that factor. Okay, so really looking at these problem sets, in all of them, there's a constant factor. And then there's a factor that changes. And we've used the same factor that changes. And really what this is called a scaling factor. So the scaling factor changes the size of the constant factor. Okay, so taking a look at this last problem set, this last example, I have my constant factor as 1/2. And I have my scaling factor, 5/5, 3/5, and 9/5. So you can start to make these predictions based on the patterns. So we know that 5/5 is 1. So the product will be equal to 1/2. We see that 3/5 is actually less than 1. So the product will be less than 1/2. And finally, 9/5 is greater than 1. So our product will be greater than 1/2. Okay, so 1/2 times 5/5 is equal to 5/10, which 5/10 is equal to 1/2. Next we have 1/2 times 3/5. That's equal to 3/10. 3/10 is less than 1/2 because 1/2 would also be 5/10. And then finally we have 1/2 times 9/5. Well, that would be 9/10. And 9/10 is greater than 1/2. And greater than 1/2. So you know that your scaling factor changes the size of the constant factor, and it impacts the product. So here's your problem set. You're going to fill in the blank with a numerator or denominator to make the number sentence true. Then you're going to look at the inequalities in each box. Choose a single fraction to write in all three blanks that would make the three number sentences true. Explain how you know. So I'm going to give you a little bit of a hint. Your hint is you're going to choose a numerator for here, a denominator, and another numerator. So remember, here's your constant, here's your constant, here's your constant. And this is going to be less than 7. This is going to be greater than 15. And this is going to be equal to 3. So remember what we know about the scaling factor in order to be less than, greater than, and equal to. Go ahead and pause. When you're ready, come back and we will correct. Okay, so you're back. You either have done this expertly or need some help. This is a tough one, I understand. So here's what we're looking at. 7 times blank over 4. Well, if I take a look at 4, I know that 4/4 is equal to 1. But I want my factor to be less than. So it has to be less than 1. So if my product is less than 7, then I need my factor to be less than 1. And 4/4 is 1, so I would go 1 smaller, which would be 3/4. Okay, letter B. Okay, 7 over something times 15 is greater than 15. So I know that this scaling factor needs to be greater than 1. So if 7/7 is equal to 1, I need this to be greater than 1. So I actually need to change my denominator. And I'm actually going to make my denominator 6, because I know that 6/7 is greater than 1. So 7/6 is greater than 1. So I have 7 over 6 times 15 would be greater than 15. And finally, equal to. 3 times something over 5 is equal to 3. Well, this is the identity property of multiplication, and we know that 5/5 is equal to 1. 1 times 3 is 3, so here we put a 5. All right, let's take a look at the inequalities in the boxes. Again, I'm going to give you some hints. These are a little challenging. We're going to look at 3/4 times something is greater than 3/4. 2 times something is greater than 2. And 7/5 times something is greater than 7/5. So these are all greater than. These are all greater than. So now, if these are all greater than, what we really want to do is we want to look at the constants. So 3/4 is a constant, 2 is a constant, and 7/5 is a constant. So you need to choose a single fraction. So you have to choose the same fraction for each problem. So really you're going to work with the largest constant factor, which is going to be 2. And so you need to find a fraction that goes into, and this will be your focus, you need to find a fraction that is greater than 2 to put into each. So take a minute, come back, and I'll explain the answer. Okay, you're either very confused or you're very confident. If I look at 2, because I know 2 is the greatest out of these 3 constants, I'm actually going to change 2. I'm going to change this into 4 halves, 4 over 2. That's the same value as 2, and it's going to allow me to find a fraction to use for all 3. So if I want to be greater than 2, or 4 halves, I have to add 1 more to my numerator. So what I would actually be adding is 1 more to 4 would be 5. So the answer would be 5 halves. 5 halves. And 5 halves, if it works for 2 because it's the greatest, it will work for all the numbers below. Okay, now let's look at B. So with B, we're looking at the constants, which are, again, 3/4, 2, and 7/5. Now, remember we're using actually 4 halves instead of 2 because it's the same value. We're just kind of converting it. And now we actually need to find a factor to multiply by so that the product is less than the constant. And it's actually less than the smallest constant. So if 4 halves was the largest constant, then the smallest constant would be 3/4 because that's less than 1. So you're going to find a fraction to put in for all 3 that would have the product be less than the smallest constant. So go ahead, take a minute, and come on back. Okay, you're back. Again, very confident or needing some help. So here's what we're going to do. The smallest fraction here is 3/4. And if I want to have my product be less than the smallest constant, I have to multiply by something that is less than 3/4. So what might be less than 3/4? Well, if I subtract from the numerator, I can go to 2/4. 2/4 is definitely, actually, 2/4 is less than 2/4 is less than 3/4, or 3/4 is greater than 2/4. So I could put in here 2/4. If you also, instead of 2/4, put 1/2, you would also be correct because 2/4 is equal to 1/2. So again, what we're doing is we're looking at a pattern and we're looking at how the scaling factor influences the product. So to end this lesson, we're looking at a scaling factor and the fact that it changes the product in a set of constant factors. For example, if your factor is equal to 1, your scaling factor, if that's equal to 1, your product will be equal to 1. Your product will be equal to the constant. factor. If your factor is less than 1, your product will be less than the constant. And if your factor is greater than 1, your product will be greater than the constant. One times 2 over 2 is equal to 1. 1 times 1 over 2 equals 1/2. 1 times 3 over 2 is equal to 3/2. So if we look at the rule, we've multiplied by 1, and our factor and product are the same. We've multiplied by less than 1, and the product is less than the constant. We've multiplied by greater than 1, and the product is greater than the constant. Thank you and best of luck.